Lesson 4-2 is add linear expressions. Now, just like always, please make sure you write down this vocabulary in your notes. Okay? You're going to write down this, and you're going to write down these sentences. Okay? A linear expression is an algebraic expression containing one or two terms in which each term is a constant or a product of a constant and a variable raised to the power of 1. Whew, that's a mouthful. So let's see. Containing one or two terms. Now remember, a term is each part of an expression. So if I have like 2a plus 4, 2a is a term and 4 is a term. Okay? Now let's take a look at this part where it says each term is a constant or a product of a constant and a variable raised to, okay, let's break that. Let's look at the first part. Each term is a constant. So that is a constant, or the product of a constant and a variable. Now product means multiply. So a constant, which is, for example, this one, 2, and a variable, a, 2a. So that's that. Raised to a power of 1. Raised to the power of 1. Now remember, if there's no number on the exponent, that means it's to the first power. So that's raised to the power of 1. So 2a plus 4, that is a linear expression. Okay? And our linear expressions cannot have a variable in the denominator of a fraction. So that means that if it looks like this, 12 over a, this is not a linear expression. That cannot happen. So based on that definition, we want to sort these expressions by writing each one in the appropriate bin. Okay? So negative 5x squared. Negative 5x squared, that's a constant. Negative 5, that's a constant. And it is the product of an exponent. Okay? But the exponent is 2. So it has to be a power of 1. So for this one, that negative 5x squared is it's not a linear expression, so it goes in a nonlinear expressions box. So this one is done. Now we have negative 4x plus 3. Well, again, we've got a constant multiplied by a variable, so that's a product of constant and a variable. The exponent of the for the x is 1, and we're adding that to a constant. So this one is a linear expression. So this one goes in the linear expressions box, and that one's done. All right, 1/2 x minus 5. Okay, now remember, it said it cannot have a variable in the denominator. This one is okay because a variable is multiplied by a constant. So there's my constant, there's my variable, raised to the power of 1, and then we are adding a negative 5, or subtracting 5. That's a constant. So this one is a linear expression. And that goes in the linear expression box. Good. over x. 6 over x. Now remember, it said in our definition that you cannot have the variable in the denominator. So, since we have this variable right here in the denominator, this one is nonlinear. Very good. This one is going to go right here. Nonlinear. And that one's done. All right, so for the last one, we have x to the third power. We can already stop because there's my variable and my exponent is 3. It has to be, the exponent has to be 1, okay? So this one is nonlinear. This one goes into the nonlinear category right there. That one's done. All right, so now we're going to add linear expressions. These two are linear expressions, and you can see that because we have a constant. We have a constant multiplied by a variable raised to the power of 1, and we are adding or subtracting that to another constant. So here, these are linear expressions, and we're going to add them together, okay? So the first thing we want to do is we want to get rid of these parentheses, okay? I want you to make sure, you guys, you write down these steps, okay? So we want to get rid of these parentheses. Now, we're going to use the distributive property to get rid of those parentheses. Now, what number is in front of those parentheses? It's a 1. Good. So what we're distributing is a positive 1. Okay? So this is going to be 1 times everything inside the parentheses there, and 1 times everything inside the parentheses there. It's a positive 1. Okay? So we are multiplying positive 1 times everything inside the parentheses. So inside the parentheses, we've got a negative 3 and a positive 8 there. We've got a positive 6x, that's a negative 3x. This is a positive 6x and a negative 12. So that's what we're going to multiply. So 1 times negative 3x, of course, is negative 3x. 1 times positive 8 is positive 8. And now our parentheses are gone. Now we have positive 1 times positive 6x. That's a positive 6x. And then positive 1 times a negative 12 is a negative 12. And now parentheses are gone. Step 1 done. Okay. Now we want to use our shapes to identify our like terms. So our like terms, we've got some x terms here. We've got a negative 3x and a positive 6x. And we have a positive 8 and a negative 12. So we're going to add up the green rectangles and we're going to add up the blue circles. Okay? So a negative 3x plus 6x. So negative 3 plus 6. That's going to give us a positive 6. Positive 3. So this is going to be a positive 3x. Do I have to put that plus in the front? No, you don't. So that's just going to be 3x. And now we've got a positive 8 minus 12. And of course, when we subtract integers, we change. So this is going to give me a negative 4. So this is going to be negative 4. So my final answer there is negative 3x minus 4. And that was step 3, was to combine the like terms. Let's go ahead and do the extra example 1, okay? So on this one, again, we are distributing positive 1 throughout the parentheses, okay? So we're going to have 1 times 5x and 1 times a negative 4. We've got a positive 1 times 2x and a positive 1 times 2. Okay, so we've got 1 times 5x, that's 5x. 1 times negative 4, that's negative 4. And now my parentheses are gone. Now for the second term, we've got 1 times negative 2x, so that's going to be a negative 2x. And then positive 1 times positive 2 is a positive 2. And there we go, no more parentheses. Now we're going to use our shapes to identify our like terms, keeping in mind that the operation is also the number that follows, so when I circle them, when I identify them, I want to include the operation. So we've got some x terms. So there's a 5x, and that's a positive 5x. And we've got a negative 2x there. And we've got a negative 4 and a positive 2. And now our step 3 is to combine our like terms. So combining the green rectangles, we've got a 5x minus 2x. So 5 minus 2, of course, is 3. So this is going to give us 3x. And then we've got negative 4 plus 2. The blue circles. So negative 4 plus 2, that's going to give us a negative 2. And again, there is our final answer. 3x minus 2. All right, so here is example 2, and we're going to throw in some fractions. Not a big deal. We just need to get common denominators, okay? So, again, just like with our other example, with example 1, we are distributing a positive 1. So when you see this, when you distribute a positive 1, okay, just like that, draw your arrows. We have 1 times 6x. That's going to give us a positive 6x. Then we have 1 times a positive 3/5. That's a positive 3/5. And now for the next one, the next expression, we have positive 1 times negative 5x. That's a negative 5x. And positive 1 times negative 1/3 is a negative 1/3. Okay? Step 2 is to use the shapes to identify our like terms. So, we've got some x terms, and we have some constants. All right, so now I'm going to rewrite with common denominators. Now, before I rewrite with common denominators, I'm going to go ahead and put the greens together and the blues together. Okay, so we've got 6x minus 5x plus 3/5 minus 1/3. Okay, so you can see these are the two parts that we're going to put together. We're going to do this part right here, the blue, and the pink. Okay, now with 6x minus 5x, remember all you're doing is subtracting the 6 minus the 5. So you're just going to write 6 minus 5 is 1. That's 1x. Now, do I need to write that 1 in there? No. So we're just going to write x. So that's that part. And now before we continue with the next one, we have to get common denominators. So the common denominator with 5 and 3 is 15. So we're going to multiply this times 3, denominator and the numerator. And the second fraction, we're going to multiply times 5 in the numerator and the denominator. Okay? So let's rewrite that. So that's going to be x plus 9/15 minus 5/15. So now this is what we're dealing with. So the x, that one's already simplified, so we just need to bring that down. So we've got x here, and then 9/15 minus 5/15 is 4/15. So this is going to be x plus 4/15. And that is your final answer. Alright, so let's do extra example number 2. So again, the first thing we're doing is we are distributing a positive 1 to get rid of the parentheses. Oops. To get rid of the parentheses. So we've got a positive 1 times positive 4, that's positive 4. And we've got a positive 1 times a positive 1/4 x, that's going to be a positive 1/4 x. And then the second expression, we've got a positive 1 times a positive 2/3 x, that's going to be a positive 2/3 x. And then a positive 1 times a negative 8 gives us a negative 8. Okay? So now use our shapes to identify like terms. So we've got some x terms here. And we've got some constants there. Okay? Now, we like to do the variable terms first, okay? So we're going to put those together. So we've got 1/4 x plus 2/3 x and this is a positive 4 here, so this is going to be plus 4 minus 8. So here are the pieces we are going to be working with. Okay? Now, with the fraction part, with the variable terms, we need common denominators because there's fractions there. Now, the common denominator with 4 and 3 is 12. So we're going to multiply the numerator and the denominator of the first one times 3, and the numerator and the denominator of the second one times 4, because that's going to be 12 in the denominator. So that gives us 3/12 x plus 8/12 x, and then plus 4 minus 8. Now, you know what we can just do 4 minus 8. What's 4 minus 8? That's going to give us negative 4. So let's just write negative 4 here. Okay? So now we're dealing this, and this one is already done. So now 3/12 x plus 8/12 x is 11/12 x. And then bring down that minus 4. And this is your final answer.